Hi guys, this video is going to cover the first section in the graphing radicals unit. We have been graphing a variety of different things. Radicals are pretty straightforward when it comes to graphing. So hopefully you've had a chance to look through this page and the back side, but I want to go through and make sure that you understand how to graph these. First of all, notice the numbers that I put in the X column. I specifically put perfect squares in there. You could put any numbers you want to, but if you put like a 5, you're going to get a decimal answer. So I only chose the X values that were perfect squares so that when I graph it, they were easy to graph. That's why I chose those numbers. This is the parent function. The parent function means that is the kind of the basic function that everything goes back to. If we look at the graph that we have, again, just taking the square roots to come up with a table, this graph is actually a lot like a parabola, but it's sideways. Let me show you what it looks like on Desmos. So here it is on Desmos. You can see it's got a 0, 0, a 1, 1, a 4, 2, etc., etc., etc. So these are the same points that we had on our graph. I wanted to show it to you on Desmos though because mine was not perfect, but also because we're on Desmos we can see, can you visualize how this is kind of a half of a parabola? It's sideways and it's only half of one. Well, why is it only half? Let's think about that. Why is it only half? Why aren't there any negative y values? Okay, that's a good question. Another one, why is it on its side? Why isn't it going the other way? Okay, so the reason it's on its side is it is the square root. You don't need to write this part on your sheet, but if we had y equals x squared, that would be like this. This one is the square root, and so it turns it on its side. But again, we don't have the negative values because we can't, there's no way to make this a negative, right? There's no number we could plug in there that would give us a negative answer. So that's why it is only half, is because there's no negatives with square roots. And the reason it's on its side is squared is a parabola, square root is kind of the opposite function of that, so it turned it on its side. So that is the basic function and what it should look like. Domain and range. Well, the domain is your x values, remember, and so any x values, what are the x values that we can plug in? Well, the only x values we can plug in are positives, because we can't put a negative under a square root. Same thing with the range. The range is the y values. It's anything outcome that is negative. Well, there's no negative outcome with square roots. So they're all positive and all positive. And that's why on this page, I want you to go ahead and make your axes on the positive quadrant only. So that is our parent function of y equals the square root of x. Well, let's look at what happens if we change that a little bit. So for number 2, all we did was add a 1 onto the end. And we know, because we've been studying functions all year, that anything that you just add onto the end of it moves it up. So that plus 1 made it a transformation of moving up 1 unit. Our graph itself did not change at all. And again, I don't need you to draw this in here, but I'm going to show you. This is where the axis, the x-axis used to be, and now I've just moved everything up 1, so it's 1 unit off of the x-axis. If we showed the other half of the parabola, it would be coming out of here and going this way. Okay, so that is what has happened with our transformations. So we have it moving up 1 unit. What that did with our table is it also moved our table up 1 unit. Previously it was 0, 1, 2, 3, 4. Now we are at 1, 2, 3, 4, 5. And so what that did is it didn't change our domain at all because our square root is still there. We still can't have a negative. So that is the same. The range, though, is there any way, if you have a plus 1, is there any way to get a 0? No, because you've got this plus 1. You can't really do that. So our range, because we moved because we transformed our graph and moved it up 1 unit, we also had to move our range up 1 unit. It can't go to 0. It stops at 1. Or in this case, it would start at 1 and go up from there. All right, let's look at the next one. Okay, on number 3, if you'll look at our square root, this time our minus 3 is on the inside. And if it is on the inside, that is a right-left transformation. The minus, when it's inside, it's like opposite of how it seems. So it's a minus, means it moves it right 3 units. So in other words, this time, my y values were the same as the original. It's my x values that changed because I had to get a number in there that would make a square root. So I knew what numbers to plug in there. I pre-selected those for you so that they would come out to be positive. So 3 minus 3 is 0, square root of 0 is 1. 4 minus 3 is 1, square root of 1 is 1, etc. So that's where we're getting this from. And so now our domain moved right 3 as well. Because think about it. What would happen if you plugged in like a 1? If you plugged in a 1, you'd get 1 minus 3, and that's negative 2. Can you take the square root of negative 2? No. And so 1 is too small. The domain now starts at 3 instead of starting at 1 or 0 or anything else. And the range, it goes from 0 and goes up. Once again, positive values only on this one. It didn't move up and down. It only moved right and left. Number 4, this time our 1/2 is out front there. That means a vertical shrink. If you look at this half of a sideways parabola, it is very, very narrow, real skinny. It's sideways, but it's real skinny. It has been shrunk vertically. It was like smushed down. Okay? If you look back at the parent function, it still had a point at 9 and a point at 4. They were just smushed down and brought down this way. So that's how I got my table. My domain is still from 0 to infinity on both the domain and the range because my square root x is the only thing under that square root sign. Another thing to notice before we turn the page is, do you remember when we had the function y equals x squared? And when we were graphing, we would always start at the vertex, then we'd go up 1, right 1, up 3, right 1, up 5, right 1, and we always had that 1, 3, 5 pattern. We still have that 1, 3, 5 pattern. It's just on its side. So now I'm going to go back. Let's go back just to the top of the page. I go up 1, right 1, up 1, right 3, up 1, right 5, up 1, right 7. So we still have a 1, 3, 5, 7, etc. pattern. It's just going in the x direction instead of going in the y direction. So it is another similarity with parabolas. When you think of these square root functions, you might think of it as a half of a sideways parabola. Okay, so everything on this page, once again, was a half of a sideways parabola. They all have axes on the x and y axis, just because that's much easier to graph them, because they're all going to be positive in a lot of ways. Now, if we had moved it to the left instead of moving it to the right, we would have gotten into some negatives. But in our case, we just moved it to the right, so that's why all of our axes were there. When we turn the page, our axes are going to be different. On this page, we want our axes in the middle. My table, instead of the perfect squares, my table has perfect cubes. And so I didn't want to go to 27, seemed excessive, so I just went 0, 1, and 8. Now, notice they have negatives. You can have negatives with cube roots. You can't with square roots, but you can with cube roots. And so these, instead of having that halfway sideways parabola, they are kind of an S shape. Okay, you see this S shape? Let me show you what that looks like on Desmos. Okay, here we are in Desmos. Can you see that kind of S shape that it has? And then it's going to continue to go forever in the positive x direction on the right and the negative x direction on the left. But it has that curve to it, that same curve. And this time, whereas before, like on the parabola, we went up 1, right 3, we're always going to go up 1, right 1 for the parent function, and the next one, down 1, left 1. So let's go back and look at our paper. All right, so mine does not look as good as Desmos, but again, I counted to -8 on the x-axis, +8 on the x-axis, and I plotted my points. I get this curve, this S shape. It does cross at 0, 0, and then goes up 1, right 1, down 1, left 1. And so that's always going to have that little curve like that in the middle of it, and then it's going to go forever to the right and forever to the left. And so this time our domain is all real numbers, or negative infinity to positive infinity, that there are no limitations. It doesn't have to stop at negatives or anything like that. We can have any numbers we want in cube roots. Let's look at some of the transformations. All right, here is on example 6. This minus 2 on the end, moved it down 2. So I just took that same S-curve and I moved it down 2 units so that it's here. My domain and range are still negative infinity, positive infinity, and then my y values did change, but that doesn't affect my domain and range at all because it's always infinity to infinity. If we look at number 7, look at the cube root, that goes left 4. That's what that plus 4 means left 4. Again, we fill in our table. We know the domain is always positive infinity, negative infinity. This time I moved my axes over just to try to fit it better. Since I knew it was going to have to be left 4, I just made some space so I'd have more room here. So I counted from negative 12 over here all the way over to positive 4 over here. You can set yours up however you want to. You don't need to change your axes if you don't want to, but I just tried to fit all of it on there that I could. And then finally, number 8, this 2 in the front is a vertical stretch by 2. On the other side, we had a 1/2 that shrank it down by a half. This time we're getting stretched by 2, and it is a vertical stretch. It's getting pulled upwards and pulled downwards over here. Still has that S-curve, just has different numbers. These are all multiplied by 2 because it was stretched by 2. And so our domain and range is still negative infinity to positive infinity. As far as HIVO goes, these are our HIVO rules. The number in front, that's like number 8, it's going to be your vertical stretch or shrink. If it's a whole number, it is a stretch. If it's a fraction, it is a shrink. Now another thing I don't have on here that maybe we should discuss is that a negative, what does a negative do? If we have it out here on the A, if we have a negative there on the A, it's going to flip it over the x-axis. It's going to reflect it over the x-axis. So that's, if there was a negative in the front of a square root, for instance, it would be the downward part of it because it would be the negative part. If it was a negative on a cube root, it would still be that S-curve, but it would be it would be upside down, something like that. So this would be a negative cube root, and this would be a negative square root. So the negative would reflect over the x-axis. Otherwise, that number there, if it is greater than 1, it is a stretch. If it's less than 1, it is a shrink. Then inside, and we don't do this very much in this class, so you don't really need to worry about that. They do that more in pre-calculus. In this class, though, the horizontal stretch or shrink is the inside. Remember, horizontal inside, vertical outside. So the vertical is the outside ones, horizontal ones are inside. Now this n is just the root, like the square root, the cube root, whatever. So that's going to give you your parent function. It doesn't transform it in any way. It just gives you your parent function. If it is inside the square root sign, that moves it left or right. If it is outside the square root sign, that moves it up and down. And just like always, that minus sign tells us it's opposite. So if it's a minus, it's actually going to the right. If it's a plus, it's actually going to the left. All right, that is all you need to know for the transformations. We'll be working a couple more days on graphing, so all of this information is basics you need to know for graphing.